In this lecture, we will be discussing about the inventory and its management. So, first of all, what is inventory? Inventory is nothing but the raw materials, the components or the parts, the work in process, or the semi-finished product, the finished products that are held at a location in the supply chain. So, there are several examples for the inventory management. Examples like hospitals, pharmacy, manufacturing industries, construction companies, supermarket, even our home. Suppose in the case of a kitchen, we consider as an inventory. So there are items, which will be in different forms. Could be in the form of raw materials, can be components, or can be work in process, semi-finished product, finished product, etc. All are located in some locations or some parts of a supply chain. That is normally called as the inventory. And management of inventory is one of the expensive, at the same time one of the complicated job. So one of the most expensive assets of many companies, representing as much as 50% of the total invested capital. Operation managers must balance inventory investment and the customer service. Now, what are the main functions of inventory? The main functions of the inventories are as follows. Number one, to separate various parts of production process. By this we can segregate, or we can divide, or we can separate various parts or the sections of the production process. To protect the firm from fluctuations in the demand and provide a stock of goods that will provide a selection for customers. So demand is always not necessarily be fixed. The demand may change or the demand may fluctuate. So if you have some management of the inventory, it is possible that we can protect the organizations from the stock out case. And the third function is to take advantage of the quantity discounts. So when you go for large quantities, definitely, or bulk purchase, there must be some kind of discounts. And we can utilize these type of facilities, if we go for inventory management. And the fourth point is to hedge against inflation, because there is change in the price of commodities or the materials. So keep in mind this inflation. By inventory management, it is possible to save for the sake of the company. As we have already said, types of inventory. The inventories are in the form of raw materials, which are already purchased but not processed. Work in process, also called semi-finished products, which is some type of transformation is already done but is not completely done. Maintenance and repair operating, because most of the industries, there are some parts or the spare parts that is required to maintain the operations of different units. And of course the finished products which are already ready and are waiting for the delivery or shipment. Now let us look at what are the different type of costs that is involved in inventory management. Normally the total cost is nothing but the summation of three things or three costs, which are number one is the purchase cost, number two is the ordering cost, and the third one is inventory cost. So what do you mean by purchase cost? The purchase cost is something but the total that expense or the total cost that is spent for the entire unit that we are going to buy. So if there are total units and this is the cost per unit, then we can say the purchase price is D times P, where D is the total units or the demand, annual demand, and the cost per unit is P. So DP will give you purchase cost. The setup or the ordering cost. For making every order, there are some costs or there are some expenses involved. And this particular cost is directly proportional to the number of orders. More the number, more will be the expenses, or the higher will be the expenses. So the setup cost or the ordering cost is calculated by the equation number of orders multiplied by cost per order. So if you are making only one order, then we have just cost per order. But if you are making more number of orders in per year, definitely we'll have more expenses here. And this is calculated by the equation C0 or CO, ordering cost is equal to D by Q into S, but D is the annual demand and Q means it is the batch size. Every batch, how much is that? How much is the quantity that is ordered in every batch? And S is the cost for one order. Third cost is called inventory cost. The inventory cost is also called holding cost. This cost is responsible for keeping or holding the items inside the warehouse. So there are a lot of expenses required, the physical expenditure such as the rent, the electricity bill, and sometimes some of the item that has to be kept in the fridge or the refrigerator. And we have the other type of security and the type of expenses, insurance expenses and so on. So all these expenses will be coming under the category of holding cost. And holding cost is calculated by the equation average inventory multiplied by the holding cost. Here we consider the average inventory just because of the fact that we are not going to keep the full quantity that is being purchased in the inventory for the entire period of time, because there is a demand, and depending upon the demand the stock is going to reduce. So in such cases we are assuming that we are considering the average inventory while considering the highest stock amount and the minimum amount. So the minimum amount is 0, the highest is Q, so 0 plus Q divided by 2, which is the average, multiplied by H. So the equation for the inventory cost or the holding cost, CH, is equal to Q by 2 into H. So now in order to get the total cost, we want to add all these three. So now what is most important to remember, there are two type of cost here. This cost, three type of cost. The purchasing cost is always fixed, whereas this cost, CO and CH, if you go for large number of orders or more number of orders, definitely we have to pay more on the ordering cost. Then if you go for large number of orders, the batch size per order will be less, so we are going to pay less for the CH. On the other hand, if you go for single order or bulk order, then we are going to save here, but we are going to spend here. So these are the two expenses which are opposite or which are inversely proportional. So the question is that what is the minimum cost of inventory such that we don't have any kind of extra expenses to be paid either as ordering cost or the inventory cost. At the same time, we should not have any kind of stock out or the shortage of inventory. Now let us look at an ideal case where this shows that the inventory management graph. This indicate the stock and this indicate the time here. So here we are making some assumptions that once we make an order and assume that the items are delivered instantaneously. So assume that in 0 time we are making an order, the warehouse will be delivered with a Q amount of inventory items. Then also we have making the assumption that the demand is fixed. So as the time passes, we can see that this stock is also going to reduce, and when the stock is become 0, the next order will be placed and we are going to get the items immediately, because this is assumption that we made. So this graph is something like a sawtooth graph, and in practical scenarios, I think this particular situation is very hard, because first thing is what demand is not fixed, and second point is that always when you make an order, it will take some time to reach or to arrive the items into the warehouse. So that's why we are assuming that this is an ideal case. So how do you calculate the average inventory? Using this equation already we have mentioned that we have minimum stock 0, maximum stock Q, so the average will be Q by 2. and number of periods, so the number of times we are going to make the orders is D divided by Q, where D is the demand, annual demand, and Q is the batch size or the quantity that is order per order. So these are the total cost here. So we have DC, which is the purchase cost, D by Q into S, which is the ordering cost, and Q by 2 into H, that is the holding cost. So in order to find the optimum quantity, we need to optimize the total cost. So optimization, that can be done in mathematics by differentiation. The only thing which that we can control is Q. So we have to differentiate this particular equation with respect to Q, because Q is the only thing that we can control. Rest of the quantities are all constants. So this is one method. Second method, that we are trying to equate between these two costs, because we have one is an increasing cost and other one is a decreasing cost. So we try to balance these two equations. So this part is the ordering cost and this is the holding cost. So if you are going to equate these two equations, we can get what we call the optimum value. So if you solve this particular equation, we'll find Q star, which is the optimum quantity that can be ordered such that the inventory cost is at its minimum. So it is calculated by the equation 2 SD divided by H. So this is one of the important equations that is to remember. Q star, which is the optimum or the optimal number of pieces. This is also called EOQ, which is called the economic ordering quantity. So if you are going to make an order of Q star items, then definitely the total inventory cost will be the minimum. Now this shows the EOQ in a graphical way. So we have expenses like holding cost, and we have got other cost is called the ordering cost. So if you are making less orders, definitely ordering cost will be higher, and if you make more orders, the ordering cost will be lower or less. The holding cost depends upon number of items that you order. So if for less items, the cost will be less, and for more items you have to pay a lot of money for the holding cost, and the total cost is the sum of this. So we can see that there is a lowest point which is supposed to be the minimum cost, and that point is normally called as the economic ordering quantity, or in our previous discussion we found that Q star. So Q star will give you the valley point of this particular graph. So let us look at one example here. Assume a car dealer that faces demand of 5,000 cars per year. So its an annual demand is D, which is equal to 5,000. Then it cost $15,000 to have cars shipped to the dealership. So the shipment cost is a part of the ordering cost, which is 15,000. Holding the car in the warehouse or something is requiring $500 per car per year. So the question is that how many cars the dealer should order so that the cost is equal to, the quantity is equal to EOQ, or the cost is the minimum. So Q dash is equal to, if you substitute all the value in this equation, 2 times 15,000 is the ordering cost or the shipment cost, and D is the demand, and divided by holding cost is 500. We'll get 548. So what is this 548 indicate? This 548 indicate that if you are going to make an order of 548 cars in one order, our cost will be the minimum. And what is the total number of orders? Total number of cars per year is what? 5,000. So how many orders we supposed to make it? It is nothing but 5,000 divided by 548. That many orders we are going to make it. And this Q dash will give you, Q star will give you the minimum cost, minimum inventory cost. So we have to order 548 cars per order. Now, as we discussed before, if the demand is fixed, but the delivery is not instantaneous, so we are making an order and assuming that the items will be delivered after some time. And the time that required for the delivery, that is known as the lead time. So if the demand is fixed and the lead time is L, right? The question is that when to order, because we cannot wait until the stock becomes zero. Then it will take, for example, if you are making an order now, it will take some time for the item to deliver. So we have some, stock out period. It shouldn't happen. So we should calculate when to make an order. And in this case, demand is fixed. So this point normally we call as a reordering point. So what is reordering point? So we should keep in mind that when to order, or we should know that when to place an order. So when the inventory or the stock is become equal to a particular point, a certain level, that is called the reordering point or reordering quantity, then we should place an order. Then exactly after L time, which means the lead time, the items will be delivered here. So we can make sure that the items are going to be delivered exactly at this instant. Then we wouldn't have any kind of stock out situation. So this is to place the order. So how do you know that this is based on the quantity? So you're going to check this quantity. How much is the quantity? That quantity is normally called as a reordering point here. So what is reordering point? The reordering point is something but when the inventory become equal to a certain level, then we have to make an order. And how much is that? That is calculated by the equation ROP. The reordering point is equal to L, which is the lead time, multiplied by the demand here. So if the lead time, for example, it is 3 days, and the annual daily demand is like, for example, 10, the lead time is 3, and the demand is 10 per day, then we can see that 3 times 10 is going to be 30. So when the stock becomes 30, so you're supposed to make an order so that the items will be delivered exactly after 3 days. Then we will not have any kind of the stock out period. So when shall we order? That is equal to ROP, which is called the reordering point. And how much shall we order? That is depend upon EOQ. So if the lead time to receive cars is 10 days, so when we should order? So in this case, because we have the demand is in terms of years. So first of all, we have to calculate how much for 10 days in terms of years. So 10 divided by 365. So this is an order per day, number of orders per day. This is 10 divided by 365. We are converting the days into 365 multiplied by the demand. So this will give you exactly what is the reordering point, which is 137. So what does it mean? When the stock become 137, we should make an order so that we wouldn't have any kind of shortage. So we should make an order 137, and how much to order? 548 cars. And as we said before, the demand is rarely predictable. It may change, it may fluctuate. And this will cause some kind of issues in the market, in the inventory. So let's see how we are going to tackle such issues. So in the case of demand is unpredictable, in such cases we don't know what is the ROP. And if you are going to choose something based on the random or some kind of what you call the random numbers, sometimes you have a situation where you are going to make an order before the stock becomes zero. So we have some surplus or extra amount of stock. The second point is that sometimes we may have a stock out point where the items become zero or the inventory becomes zero before the new delivery happen. So this happens when the actual demand is greater than the expected. We call as the stock out. Whereas this happen, the actual demand is less than the expected demand. As a result, we have a surplus or extra amount of stock. So we should have some extra spaces for handling such extra items. So here we have some unfilled demand, and here we have some kind of the lead time. So normally to manage this based on some kind of statistical method, that will be discussed in the following class. So this is the basic idea about the inventory management, and in almost all the fields, inventories are there. Okay, inventory management is there. So our main idea is to cut down the total expenses by making or by controlling either of the expenses, either the holding cost or maybe the holding, the ordering cost. Okay, thank you.